Hey, let's do some more problems from 6-3. These are even numbers, 22 through 44. That's the ones we're going to do. That's like 12 problems or something, I think. All right, let's see what we can do. Number 22, we've got x squared plus 1 over the square root of x cubed plus 3x du. So what you can do with that? Well, we're trying to find the antiderivative of this. So it's not just like look at it and recognize what it is. So probably use substitution. What are you going to try here? Maybe it's not like super obvious what's going to work, but when in doubt, pick the thing that looks most like the what's inside and take your chances. Roll the dice. So let's see, du here is going to be 3x squared plus 3 du, and that actually is going to work because that's the same as 3 times x squared plus 1 du. So what I need is a 3 here, which I can balance with a 1/3 out there. And then we are ready to rock and roll. So 1/3, all this gets sucked up by the du, and that should be a dx there, sorry, getting ahead of myself. Now it's a du, and then 1 over the square root of u, also known as u to the negative 1/2. So 1/3, bump that exponent up 1, and divide by the new exponent. Dividing by 1/2, same as multiplying by 2. So that's 2/3 times u, that's a 3, promise, to the 1/2 plus c. Then a quick check. What? 22. No, that's right, sorry. I was looking at the wrong one. It had 3/2, but 2/3 is right. 24. Sine of 1 over x over 3x squared dx. That looks the most like the what's inside to me. I was going to write dx there, but not yet. So then du is equal to negative x to the negative 2 dx. And hey, I've got an x to the negative 2. That's an x squared on the bottom. I don't really want that 3 to be there, so I think I'd rather that that was on the outside. I just slide that across. It's going to be on the bottom when I move it outside because it was on the bottom here. And what I would like is for there to be a negative sign in here, so I'm going to need a negative out there also. So I've got negative 1/3 times the integral of, I've got negative x to the negative 2 dx. That all gets swallowed up by the du, and then sine of u. Antiderivative of sine is negative cosine, so that's going to flip that to positive 1/3 cosine of u plus c. That's good. 26. X to the cubed. That's not how you say that. X cubed times e to the x to the 4. Okay. Remember with the e, it's like the what's up there is like the what's inside. So du is 4x cubed dx. So x cubed dx, that's good. Now, going to need a 4 there, so I'll put a 1/4 on the outside. And that all gets packaged up du, and that's just e to the u. So that's 1/4 e to the u plus c. I'm kind of skipping that step where when I was doing the odds in the last video, I was writing out one more step in between here where I wrote out the antiderivative with the u in it. But if it's real easy, depending on how complicated the problem is, I think you could get away with skipping that step. Here's one that looks not so simple. All right, here's a hot tip for you. If you're looking at something like this one, say, and you're like, I don't know, really don't know what to do here. I'll tell you what, if you just made like u equal to e to the x or e to the negative x or something, it's not going to work. You can try it, but you need something to be like here, to be like factored out with the dx. If you have like a bunch of addition and subtraction with your du's, that's not going to work. So when you're really kind of stuck and there isn't something that's obviously the what's inside, one thing that you can do, that you can try, is try making the denominator, the whole thing, equal to your u. It's not going to work to make the numerator the u, because then like the du has to show up on top. You can't ever have the du on the bottom, and that's just not going to work. So what if we did this? Then what's the derivative of that? The derivative of e to the x is e to the x, and then the derivative of minus e to the minus x is minus e to the minus x times the derivative of what's inside here, which is negative 1. So that's going to flip that sign. And then you can see that actually is this. Sorry. So that is going to work, because that turns this into 1 over u, and then all that is du. So that's natural log of u plus c. I think that one was a little tricky, but I mean, there aren't that many possible things you could try, so you just have to, I think, not be too afraid of doing something wrong. Here's another tricky one. So you might think, oh, okay, just make the bottom, that'd be, but if you just made the whole bottom equal to the u, then you got a t cubed, right? Your du would be 4t cubed dt, and I don't have a t cubed there, and I can't, the only thing we can do here, our little balancing act, like this, we can only do that with constants. We can't like import extra variables like x's or t's or whatever they are. That is not allowed. This is a semi-permeable membrane, if you're into biology kind of stuff, and the semi part of it is the only thing that can go across this, in and out, are constants. T's, variables, cannot. So what are we going to do? What does this look like? Well, maybe you have a notion that this looks like 1 over 1 plus u squared. What if it was that? What if what if we could turn that t to the 4th into a u squared? Well, if u squared is t to the 4th, then u would be equal to t squared, and then du would be equal to 2t dt. And I do have a t there, so that could work. So I'll put a 2 there and a 1/2 here, and then see what's what. So this is all just the du, and then I have 1 over 1 plus u squared. So that worked. That is a little tricky, I think. Tangent inverse of u. I think you can learn something by taking the derivative of this carefully and seeing if it gets back to, seeing how, not if, because we know that's what it's got to be. If you take the derivative of that and get it back to the original problem there. 32. Well, there seems to be pretty clearly a what's inside here. So I'm going to go for it. And, I start to get a little bit of experience with these things, and maybe you see this one, you're like, oh yeah, I've seen this game before. So I need a 1/2. I've got the x to the negative 1/2. That's my x to the 1/2 on the bottom. That's good. I just need that 1/2. And if you want a 1/2 in there, you're going to have to put a 2 on the outside to balance. So 1/2 x to the 1/2 on the bottom, dx, that's all the du. And then secant squared u. Antiderivative of secant squared is tangent u plus c. All right. So how about this one? So if we write it in the more calculus-friendly way of writing it, I think we have pretty clearly our what's inside. So if u is sine 2t, then du is equal to 2 cosine 2t. And that means this turns into, let's see, I need a 2 there, so I'll need a 1/2 out here. 1/2 u to the 5th du. You could write that as sine to the 6th 2t plus c, if that makes you happy. 36. Cosine 4 theta 1 plus 2 sine of 4 theta to the 4th. Alright, so u is equal to, this looks pretty convincing as a what's inside, don't you think? So 1 plus 2 sine 4 theta. Du is equal to, derivative of that is 0. Derivative of 2 sine to the 4 theta is 2 cosine 4 theta times the derivative of what's inside, which is going to turn that into an 8. So good here, except I don't have the 8, so I need that there, and then a 1/8 on the outside. So that's going to be 1/8 integral. That all turns into the du, and then u to the negative 4. So that's 1/8. Add 1 to the exponent and divide by the new exponent. So that looks like negative 1/24 times u to the negative 3. That's number 36. Oh, I have one more on that page. What are we going to, 44, I think? 8 more? Number 38. Tangent cubed 5x, secant squared 5x. Maybe it's totally unfair the way I just wrote that, because I wrote it that way knowing or thinking that I know where it's going. I'm pretty dang sure. As you sniff around these things and try to figure out like what is the right move to make, you want to think about like what is the derivative of what, and like what things are lying around. Like here, there's this cosine that was lying around here. So, if you make the u something with a sine in it, the derivative of that's going to be a cosine, so that's good news. And like here, that x to the 1/2, what the heck's that doing on the bottom? Well, when you take the derivative of x to the 1/2, it's 1/2 x to the negative 1/2, so there it is. And here, I'm thinking, well, I know that the derivative of tangent is secant squared, so this is looking good. I mean, that's also, it looks like it could be a what's inside, but the derivative of secant is secant tangent, and there are secants and tangents there. What do you think about if that would work or not? But there are more secants than there are, there's more tangents than there are secants. So anyway, this is the way to go. And I'm not going to argue with you if you think to yourself, you're thinking, man, that's kind of tricky to get that one. I'm not going to argue. It's a little tricky. You know what else is tricky? It's tricky to rock a rhyme that's right on time. It's tricky. Let's see. So this turns into, I need a 5 here. Put that there. So I need a 1/5 on the outside. U cubed, add 1 to the exponent, divide by the new exponent. Don't forget to add c. U to the 4th, you can put the little 4 there if you want to, over 20 plus c. All right. Home stretch, maybe. So let's see, we've got sine theta cosine squared theta plus 1. That might send you thinking about trig identities, but since sine squared plus cosine squared equals 1, that cosine squared theta plus 1, I don't know if that's going to get you much. So, I don't know, try different things. Making this equal to the u is not going to work, because then you're going to get like a u, the du is going to be like some weird thing on the bottom. That's just not happening. You can't make the u equal to cosine squared plus 1, because the derivative of cosine squared has a sine and a cosine in it, and I don't have that here. And even with like trig identity stuff, it's not going to work. So what if you just made u equal to cosine theta, and then du was equal to negative sine theta d theta, negative sine. Now what does that look like? So negative sine theta d theta, that's just the du. Nothing left on top. And then that would be u squared plus 1. Oh, snap. It's the College Board's favorite thing. Negative tangent inverse of u. Yeah. You got to explore the options and see what you can do. Not always obvious. With practice, with experience, after you've been teaching calculus for 17 years, you too can spot the best u substitution in just a matter of seconds. So sine of theta times the cosine of theta. Now this that definitely feels like it has a what's inside. Like this is more inside, right, than anything else. So I'm going to go for that. Sine theta du is equal to cosine theta d theta. Oh. So that's going to be sine of u du. The antiderivative of that is negative cosine of u. Why did I write that there? That was weird. I meant to write a plus c. I was trying to go just a little bit too fast. Beware. That's when mistakes happen. I just want to check that, make sure that we're good. Yep. And 44, last one. What are we supposed to do with this? So what's the square root of e to the x? This is just the square root of e to the x is the same as that, which is the same as that. And then once we realize that, that's actually one of those easy ones, like at the very beginning of the odds from the last assignment, where the only thing here happening to that x is just this is just a linear factor of x, so I just have to divide by that, and that's it. That's what else to tell you about that? That is it. That's all you need to do. All right.